Hello students, this is Pandit and today we are starting the structural analysis with the first chapter of determinacy and indeterminacy for the structures. Now let's start this topic with a very basic term, that is stability. What is stability? किसी भी चीज को स्टेबल अगर बोला जाता है तो स्टेबल का मतलब होता है उस बॉडी में मूवमेंट नहीं होने चाहिए. There should be no movement. Layman language, if you want to understand, then for the stability, the body should not move. It should be in its actual position. Whatever the force is acting on that particular body, that force should not be able to move that particular body or the structure. Then the structure will said to be stable. In the structural analysis, there are two types of stabilities. One is the external stability, another is the internal stability. External stability. Another is the internal stability. Internal stability. External stability is basically related to the support condition. This is related to the support conditions, and the internal stability is basically related to the geometry of the structure. Geometry of the structure. As I told you that stability means there should be no movement. It means that the external stability means there should be no movement externally. And the internal stability means the internal parts of the structure should not move. It means that the external stability is basically depending upon the support condition because supports are handling or holding the structure. On the other hand, the internal stability related to the geometry of the structure because the structure has a certain geometry which has to be conserved, which has to be prevented against any type of movement. That is known as the internal stability, which is related to the geometry of the structure. कोई भी structure एक support के ऊपर रखा होता है. When you will apply a certain load over that structure, then structure will try to move, but the support which are present below the structure will prevent the structure from such movement. For example, if you have this structure which is present here, if you have a structure like this which is present here, and this structure is supported over a certain support. For example, this is the support on which this structure is present. This is the support. This is the support which is present here. This is the support which is present here. It means that when you will apply the certain loads over this structure, when the load will be acting over this structure, then due to that load, there can be the movement of this structure. But these supports which are present, these supports will develop an opposite reaction. These support will develop an opposite reaction in order to resist the effect of these external forces which are acting. It means that the support will develop the same type of reaction as the force is acting. It means that if you will try to rotate the structure, then this reaction develop on this particular support will be moment. It means that externally the body is being restored or the body is being prevented against any type of movement with the help of the reactions which are developed at the support only. These reactions will get transferred internally into the body of the structure, and internally the body of the structure will be prevented due to the presence of these internal forces. The internal forces which is being transferred inside the body of the structure, which will resist the internal movement of the structure, internal movement of the parts of the structure, are known as the internal forces. These forces will prevent the geometry of the structure, that is the internal movement of the structure which is related to the internal stability. These internal forces can be axial force, these internal force can be shear force, these internal force can be bending moment. ये मैंने आपको स्ट्रेंथ ऑफ मटेरियल में समझाया है. These can be the three different types of internal forces which can present inside the body. Fine. It means that for the body to be stable, it should be externally stable as well as it should be internally stable. अब सबसे पहले let's talk about external stability. Let's talk about external stability. अगर आप एक्सटर्नल स्टेबिलिटी की बात करते हो तो एक्सटर्नल स्टेबिलिटी स्ट्रक्चर तब कहा जाएगा when there are no large body deformation, when there are no large body displacements or deformation. You can say that displacement नहीं हो ज्यादा at the support. There is no large body displacement at the support, and the structure to be known as externally stable. It means that there should be enough number of reactions produced at the support. There should be enough number of reactions that must be produced at the support. वही रिएक्शन ही तो इसको स्टेबल बनाएंगी, वही तो मूवमेंट को रोकेंगी. ठीक है, एक तो नंबर ऑफ रिएक्शन प्रॉपर तरीके से प्रोड्यूस होने. दूसरा, द सेकंड पॉइंट विच यू हैव टू कंसीडर इन एक्सटर्नल स्टेबिलिटी इज दैट देयर अरेंजमेंट शुड बी एडिक्वेट. देयर अरेंजमेंट should be adequate. Arrangement should be adequate. Arrangement का मतलब होता है there are certain conditions that the reactions which are produced should not be parallel. These reactions should not be parallel. अगर parallel होंगी तब भी fail हो जाता है structure even there are sufficient number of reactions. It means that there are certain conditions, they should not be parallel, they should not be concurrent, they should not be concurrent. They should not be trivial, the non-trivial होना चाहिए. तो all these conditions are there which you have to consider while considering the stability of the body. For example, as I told you, there should be the enough number of reaction that must be developed at the support in order to prevent the movement. What are the enough number of reaction? If you are considering a 2D case, two-dimensional case you are considering, then the enough number of displacements which can act on the support. क्या क्या displace हो सकता है? या तो body x axis पे move कर सकता है, या बॉडी y एक्सिस पे मूव कर सकता है, या फिर ये बॉडी z एक्सिस पे रोटेट कर सकता है. दिस कैन बी द मूवमेंट. इट कैन रोटेट अलोंग द z एक्सिस और यू विल राइट इट थीटा. इट कैन रोटेट अलोंग द z एक्सिस. अगर xy प्लेन की बात करते हो तो इट मींस दैट देयर कैन बी थ्री टाइप ऑफ मूवमेंट व्हिच कैन बी प्रेजेंट फॉर अ 2D केस. Either the body will move in x direction or it will move in y direction or it will rotate along the axis which is coming towards you. बाहर आ रहा है कंप्यूटर से निकल के, वो एक्सिस z एक्सिस होती है. It means that there can be three movement. It means that for the structure to be stable, these three types of movement should be prevented. In order to prevent these type of movement, there can be the equations which are known as equilibrium equations. Equilibrium equations are those equations which are created or which are present in order to prevent the body displacement. The equilibrium equation to handle this x displacement, this will be fx equal to 0, that is summation of fx equal to 0, that is equal to summation of fy equal to 0, and that is equal to summation of mz equal to 0. If these equations are present, then the body will be stable along that particular plane. It means that the total number of equilibrium equations are 3. Equilibrium equations are 3. अगर equilibrium equation की बात करते हैं तो these are 3 in number. ये 3 हो गई equilibrium equation. तो अगर आप बात करते हो external stability की, तो it means that there should be enough number of reaction that must be developed at the support. It means that the enough number of reaction means the reaction should be either equal to 3 or more than 3. If the reactions are 3 or more than 3, then there will be no displacement. It means that for the body to be externally stable, for the structure to be externally stable, there should be at least 3 number of reactions developed, at least 3 number of reactions developed at each support at least. But the condition is that they should not be coplanar, they should not be collinear. For example, if you have this beam, this is a simply supported beam, for example. In simply supported beam, you can know that the hinge reaction is R1 and this is H1, सब सोम में पड़ा हुआ है, and this is R2. It means that the total number of reaction, if you will consider for the support, then RE is equal to 3. 3 number of reactions are present. It means that the reactions are 3 and the number of equilibrium equations are 3. It means that the excess number of reactions are, अगर आप निकालना चाहते हो यहाँ पे stability, तो stability will be 3 minus 3. It means it is 0. It means it is stable. It means this structure is stable because there are 3 number of reactions required and 3 number reactions will develop at the support. 3 reaction equilibrium की होनी चाहिए, 3 movement हो सकते हैं और 3 ही movement prevent हो रहे हैं. On the other hand, if the beam is like this, if the structure is like this, अगर structure कुछ ऐसा बन रहा है कि reactions आपका इस तरीके से, they are reactions, these are the reactions, this is R1, this is R2. In that case, there is no other reaction prevent. Then यहाँ पे एक चीज ध्यान रखना, because of this R1 and R2, these reactions are parallel. This type of stability is known as linearly unstable. This is linearly unstable. Linearly unstable क्यों? अगर मैं इसे यहाँ पे फोर्स लगाता हूँ तो इधर मूव कर जाएगा पूरा का पूरा. Because in order to prevent this type of movement, there is no resultant force. So these things you have to consider. कि आपको ये चीज कंसीडर करनी है यहाँ पे. One thing you have to remember, for a 2D case if you are considering, then for the stability there should be at least 3 number of reaction developed at the support. If you are considering 3D case, if you are considering a 3-dimensional case, and a 3-dimensional case, the movement can be delta x is equal to 0, x में displacement हो सकता है, delta y is equal to 0, delta z is equal to 0. Movement can also be on any plane. This is theta x is equal to 0, theta y is equal to 0, and theta z equal to 0. It means that in order to prevent the sixth type of movement, there should be at least 6 equilibrium equations will be present. There should be the reaction that must be equal to 6 reactions are required. It means that for a 3D case, the number of reactions which will be required for the structure to be stable, that will be 6. ध्यान रखना, that will be 6. इतना आपको ध्यान रखना है. Generally, under static equilibrium condition, static equilibrium condition मतलब movement नहीं हो रहा है. Static equilibrium conditions, there will be no rigid body displacement. Displacement नहीं होते हैं support में अंदर on support, but small displacements can be there. But ये statement objective के लिए ध्यान रखना, but small elastic displacement may occur. बड़े बड़े डिस्प्लेसमेंट नहीं होते सपोर्ट के, स्मॉल इलास्टिक डिस्प्लेसमेंट कैन अकर. दिस यू हैव टू रिमेंबर. इतना आप ध्यान रखना है स्टेबिलिटी के लिए. इट मींस दैट नाउ वी हैव कैलकुलेटेड द एक्सटर्नल स्टेबिलिटी. हाउ द एक्सटर्नल स्टेबिलिटी विल बी कैलकुलेटेड? दिस एक्सटर्नल स्टेबिलिटी विल बी कैलकुलेटेड बाय कैलकुलेटिंग द number of reactions. You will calculate the number of reactions, then you will subtract that reaction with the equilibrium equation. If this value is greater than equal to 0, then the structure is said to be stable. If this value is less than 0, this will be unstable. Now next case, internal stability. After external stability, let's come to internal stability. इंटरनल स्टेबिलिटी की बात की जाती है तो इंटरनल स्टेबिलिटी, नो पार्ट ऑफ द स्ट्रक्चर शुड मूव रिलेटेड टू द अदर पार्ट. बेसिकली नो इंटरनल पार्ट ऑफ द स्ट्रक्चर should move relative to another part. No internal part of the structure should move. As I told you, internal stability is basically related to the geometry of the structure. The geometry of the structure should be preserved. It means that all the parts should remain in their position only. They should not move. Small elastic deformations are every time present. Small इलास्टिक डिफॉर्मेशन प्रेजेंट होते हैं, उनको इग्नोर कर दिया जाता है. स्मॉल इलास्टिक डिफॉर्मेशंस कैन अकर हियर आल्सो. वहां भी हो सकते थे, यहाँ भी हो सकते हैं, बट उनको आप डिटर्मिनेसी में और स्टेबिलिटी में, यहाँ पे खासतौर से स्टेबिलिटी में आप उसे कंसीडर नहीं करते. इट मींस दैट फॉर द स्ट्रक्चर टू बी इंटरनली स्टेबल, उसके अंदर के पार्ट मूव नहीं करने चाहिए एक दूसरे के रिस्पेक्ट में. ऐसा नहीं है कि एक पार्ट मूव करके दूसरा अपना रुका हुआ, नहीं. द ज्योमेट्री ऑफ स्ट्रक्चर शुड बी प्रिजर्व्ड. स्मॉल इलास्टिक डिफॉर्मेशंस आर ओके, फाइन. To preserve this geometry, what is the case? In order to prevent this geometry, there should be enough number of members. In order to preserve this geometry, what should be the case? There should be enough number of members. Present. एक तो member proper होने चाहिए, ऐसा नहीं एक आध कम member है तो अपने आप खिसक जाएगा. Enough number of members प्रेजेंट होने चाहिए वहां पे. दूसरा, एंड द अरेंजमेंट शुड बी एडिक्वेट. देयर अरेंजमेंट, वहां पे क्या था? इनफ नंबर ऑफ रिएक्शंस. इन देयर अरेंजमेंट, या इनफ नंबर ऑफ मेंबर की बात कर रहे हैं. शुड बी, देयर अरेंजमेंट शुड बी एडिक्वेट. अरेंजमेंट भी उनका एडिक्वेट होना चाहिए. इट मींस दैट दिस शुड नॉट बी द केस ऑफ मैकेनिज्म फॉर्मेशन. Formation should not present. Mechanism formation का मतलब होता है continuously the presence of 3 collinear hinges. For example, if a structure is like this, and in this structure there is a hinge here, there is a hinge here, there is a hinge here, and because of these 3 hinges which are collinear, the structure will collapse like this. The structure will collapse. This is known as collapse, which is due to the presence of mechanism. And what is mechanism? Mechanism is the presence of 3 collinear, इससे मैंने सो में भी बताया, hinges. Presence of 3 collinear hinges together will lead to the formation of mechanism which can directly lead to the collapse of the structure. This is मैकेनिज्म। तो इंटरनल स्टेबिलिटी के लिए क्या क्या होना चाहिए? एक तो आपका प्रॉपर अरेंजमेंट होना चाहिए, मैकेनिज्म नहीं होना चाहिए। दूसरा चीज, देयर शुड बी इनफ नंबर ऑफ मेंबर्स। अगर आप बात करते हो दो तरीके के मेंबर्स होते हैं। अगर आप बात करते हो मेंबर्स की इंटरनली, तो इंटरनली देयर आर टू टाइप ऑफ मेंबर व्हिच कैन बी क्लासिफाइड। वन इज पिन जॉइंटेड मेंबर and another is rigid jointed member. Rigid jointed members, pin jointed and rigid jointed members. पिन jointed members का मतलब होता है वो जो members होंगे वो सारे members और members will be able to handle only one force, that is axial force. That is axial force. They can handle only axial force. All the members can handle only axial force in pin jointed case. Pin jointed में सिर्फ axial force handle कर सकते हैं, सारे के सारे hinged होते हैं. They all are hinged. सब hinged together होते हैं सारे. Rigid jointed frame की बात करते हो तो in rigid jointed frame there can be enough number of forces. In rigid jointed frame there can be three types of forces. That can be axial force, that can be shear force, and that can be the bending moment. But so these rigid jointed member can handle all these type of forces, but the pin jointed member can only handle axial force. ये axial force ही handle कर सकता है। ये hinge होता है तो इसमें bending moment भी आपका जीरो हो रहा होता है और shear force भी यहाँ पे जीरो हो रही होती है इसके पास। तो इसके पास ना तो ये bending moment handle कर सकता है ना ये shear force handle कर सकता है। जैसे आप ट्रस देखते हो, ब्रिजेस वाला ट्रस जो होता है वो pin jointed होता है। सारी फोर्सेज जो भी उसके मेंबर में फोर्सेज होती हैं, ऑल द फोर्सेज आर एक्सियल फोर्स ओनली. दे कैन नॉट हैंडल बेंडिंग मोमेंट, दे कैन नॉट हैंडल shear force. Similarly, if the frame is rigid jointed, then it can handle axial, shear and moment, all the type of forces. It means that the structure rigid jointed की अगर आप बात करोगे तो rigid jointed में तो mechanism की problem नहीं होती है. There cannot be the formation of not mechanism. Yeah, you can say that there is no mechanism formation. क्यों नहीं हो सकता है mechanism formation? क्योंकि hinge नहीं होता. Mechanism तभी होगा when the hinges are coming together. It means that the mechanism case is with pin jointed. Pin jointed में as all the members are hinged, so it can be the case that there can be the presence of mechanism formation. So in that case, with result to this pin jointed case, their arrangement there should be enough number of members. एक तो enough members होने चाहिए. जनरली ये तो इंटरनली स्टेबल ही होते हैं आपके पास, ये स्टेबल जनरली होते ही होते हैं. पर इनके साथ प्रॉब्लम क्या होती है? ये जनरली इंटरनली दीज आर द रिजिड फ्रेम्स आर इंटरनली जनरली दे आर इंटरनली स्टेबल, क्योंकि रिजिड होते हैं, मूवमेंट होता ही नहीं है इनमें एक दूसरे के रिस्पेक्ट में. सारी फोर्सेस तो ये लोग न्यूट्रलाइज कर देते हैं. बट दीज पिन जॉइंटेड आर इंटरनली अनस्टेबल, तो बिकॉज ऑफ दिस देयर शुड बी इनफ मेंबर्स शुड बी प्रेजेंट एंड आल्सो द अरेंजमेंट शुड बी एडिक्वेट. द अरेंजमेंट शुड बी एडिक्वेट. अगर आप बात करते हो इंटरनल स्टेबिलिटी की ट्रसेस के केस में, पिन जॉइंटेड के केस में, तो जनरली हम ये मान के चलते हैं कि क्लोज्ड ट्रायंगुलर ब्लॉक्स शुड बी फॉर्म. क्लोज ब्लॉक्स होने चाहिए, तभी आप ट्रस में देखना, ट्रस में ट्रायंगुलर ब्लॉक्स बार बार ट्रायंगुलर क्लोज होते हैं. इट मींस दैट फॉर इंटरनल स्टेबिलिटी देयर शुड बी इनफ नंबर ऑफ there should be enough number of closed triangular blocks. ट्रायंगुलर ही होना चाहिए और कोई पॉलीगोनल नहीं, क्लोज ट्रायंगुलर ब्लॉक्स. अगर क्लोज ट्रायंगुलर ब्लॉक्स प्रेजेंट हैं तो दैट स्ट्रक्चर विल बी 100% स्टेबल. दैट विल बी 100% स्टेबल. ठीक है, अब मेंबर्स की बात करते हैं. अब एक बेसिक सी बात करते हैं, कॉन्सेप्चुअल बात करते हैं. रटने की जरूरत नहीं है, सब कुछ कॉन्सेप्ट से हो जाएगा. रटोगे तो कंफ्यूज हो जाओगे. बहुत सारी चीजें हैं यहाँ पे, बहुत सारे फॉर्मूले हैं यहाँ पे. देखो, as I told you, there should be enough number of members and each member will be carrying axial force. Let's say the number of members which are present in the structure, that is M. It means their number of axial forces will be same. Number of axial forces, जितना member होगा उतना axial force होगा. So we are considering there are M number of members, and so that the axial forces, the number of axial forces will also be equal to M. Fine. Pin jointed केस की बात कर रहा हूं मैं, pin jointed की बात कर रहा हूं. Now, for each joint, हर joint पे अगर आप बात करोगे, there can be two different displacement. Each joint, the number of displacement, कितनी चीजें मूव कर सकती हैं. देखो, मूव वही कर सकती है चीज जिसको हैंडल नहीं किया जा सकता है, जिसको रोका नहीं किया जा सकता है. पिन जॉइंटेड का हर जॉइंट क्या होता है? हिंज होता है. उस पर डेवलप हो रहा होता है एक्सियल फोर्स। तो एक्सियल फोर्स को तो वो रोक सकता है, बट दो चीजों को नहीं रोक सकता है वो। एक तो वो शियर फोर्स को नहीं रोक सकता, it cannot handle shear force, and also it cannot handle bending moment. It can be the case that at each joint there can be two displacement, there can be two type of movements, दो displacements हो सकते हैं। Let's say there are j number of joint, j is the number of joint, j is the number of joints. It means that the total, if j is the number of joint, then the total displacements, then the total, ध्यान से समझते रहना, डिस्प्लेसमेंट विल बी, हर डिस्प्लेसमेंट पे, हर जॉइंट पे दो तरीके का डिस्प्लेसमेंट हो सकता है। जे नंबर ऑफ जॉइंट है, देन द टोटल डिस्प्लेसमेंट विल बी 2j। हर पे दो डिस्प्लेसमेंट है, कौन कौन से? शियर फोर्स और बेंडिंग मोमेंट की वजह से। जॉइंट कितने टोटल? जे जॉइंट है, तो इसका मतलब टोटल डिस्प्लेसमेंट कितना हो गया? 2j। इसका मतलब देयर आर m टोटल मेंबर्स, m इज द मेंबर्स, and the total movement or the total displacement will be 2j. Total displacement is equal to 2 into j, which is due to the forces, which is due to the presence of forces. M is the members, also it is equal to the amount of, or the total amount of axial force which is present, axial forces which is present. इसका मतलब ये है कि यहाँ पे एक चीज क्लियर है कि the total amount, number of axial forces is this much, the total amount of displacement is this much. Out of this displacement, out of this 2j displacement, we have already selected three equilibrium equation. We have already selected three equilibrium equation. It means that we have already subtracted three types of displacement for external case, जो support पे आ रहा था। तो इसका मतलब अभी internally, this is the total amount of forces, which total amount of displacement you can say that, and out of this displacement, the three we have already prevented by the use of support. It means that the total internal displacement will be 2j minus 3. This will be the total internal displacement. यही हो गया। अभी केस ये बनता है कि बॉडी डिस्प्लेस नहीं होनी चाहिए इंटरनली, बॉडी डिस्प्लेस नहीं होनी चाहिए, मतलब जो उसके मेंबर हैं, दीज आर द मेंबर्स, कितना डिस्प्लेसमेंट हो सकता है उनके बीच में? 2j minus 3 डिस्प्लेसमेंट हो सकता है। It means that for the structure to be internally stable, for the structure to be internally stable, the number of members are m, the movement which can be present is 2j minus 3. If there is stability present here, this should be greater than equal to 0. This should be greater than equal to 0. It means that if number of members minus 2j minus 3, this will become equal to 0. It means जितना member है उतना displacement, forces ने सब कुछ cancel कर दिया, कोई displacement नहीं हुआ. It means that this is equal to 0. It means the structure will be stable. अगर आपने बात किया m minus 2j minus 3, this is greater than 0. If this is greater than 0, इसका मतलब number of members ज्यादा है, displacement कम हो सकता है. It means that it is overstable. It is overstable, which is also known as overstiff. बहुत ज्यादा stiff structure है. If this m minus 2j minus 3 is less than 0, if this is less than 0, it means the number of members are less as compared to the displacement. इसका मतलब there will be certain displacement which will be present. It means that this particular structure is deficient, and this particular structure is unstable internally. This is internally unstable. So these are the cases. In order to measure the stability of the structure, you have to calculate the external stability. Also, you have to calculate the internal stability. Both the external and internal stability will result into the formation of the total stability. Let's take the example here. Let's consider one example question so that you can easily understand what I am exactly saying. Concept समझ लेना, concept, CONCEPT. For example, you have this particular frame. This is the frame which you have. For example, let's say we have this particular frame. ये हमारे पास frame है. For this frame, we have division like this, and इसमें लगा हुआ है आपको support. This is a support, hinge support, and this is a roller support. This is question number, example question number 1. आपको पता है, you have to, all these points are hinged. ये सारे hinged point है. All these are hinged. ये सारा hinge है. Now the point is that they are asking you to calculate the internal stability. So सबसे पहले m, number of members. Number of members 1, 2, 3, 4, 5, 6, 7. It means there are 7 number of members. Now you will calculate 2j minus 3. Displacement कितना हो सकता है? j मतलब 1, 2, 3, 4, 5, 6. This is 2 into 6 minus 3. This is 12 minus 3. That is 9. It means that this m is less than 2j minus 3, or you can say that m minus 2j minus 3, this is less than 0. So this type of structure is unstable structure. This is unstable. ये unstable हो गया. Fine. Example question 2. Second question देखो, धीरे धीरे कॉन्सेप्ट पकड़ लेंगे. सेकंड क्वेश्चन में केस आपको कुछ ऐसा दिया हुआ है. दिस इज द फ्रेम यू हैव, द सेम फ्रेम यू हैव. नाउ देयर इज अ लिटिल डिफरेंस हियर. द डिफरेंस इज दैट ये तो यहाँ पे ऐसा ही है, बट यहाँ पे द कनेक्शन इज लाइक दिस. दिस इज द कनेक्शन. आपने एक मेंबर बढ़ा दिया. ध्यान रखना, मेंबर बढ़ाओगे तो स्टेबिलिटी बढ़ेगी, क्योंकि m बढ़ेगा तो 2j माइनस 3 के ऊपर जाएगा. 2j माइनस 3 के ऊपर जाएगा तो वो m माइनस 2j माइनस 3 ग्रेटर देन 0 हो जाएगा. कॉन्सेप्ट समझना है. दिस इज m. ना पहले 7 थे, 2 मेंबर बढ़ा दिया, m is 9. नाउ 2j माइनस 3 ज्वाइंट उतना ही है. दिस इज ऑल्सो 9. तो दिस पर्टिकुलर स्ट्रक्चर विल बिकम स्टेबल. ये क्या बन गया? स्टेबल स्ट्रक्चर. दिस वाज अनस्टेबल स्ट्रक्चर. और देखो, मेंबर बढ़ाते चले जा रहे हो. अगेन नेक्स्ट क्वेश्चन, question number 3, example question. Now what you are considering? Now the member is certainly like this. For example, this is the frame you have. This is the frame you have. Now for this particular frame, the case is like this. This is the division which you have. Now for this division, now you have increases the member like this. You have increases the member like this. पूरा member ही बड़ा मार दिया. सारा पूरा का member हर जगह extra बढ़ा के रख दिया. Now the case is like this. You have this support. This is the hinge support. This is a roller support which is present here at this section. Now the number of members will be 11, 7, 8, 9, 10, 11. The number of joints are same which were earlier. It means 2j minus 3 is equal to 9. Joint नहीं बढ़ाए हैं. Now m is greater than 2j minus 3. So this is overstable. This structure is overstable. इसका मतलब जैसे जैसे मेंबर बढ़ाते चले जा रहे हो, the structure is becoming stable. Continuously stability उसकी increase चली जा रही है. एक और चीज देखते हैं. Question number 4. Example question number 4. This is the structure. ये आपके पास एक फ्रेम दिया हुआ है. Now you have a division like this here. This is a division here. Now the case is that you have this type of case, and here you have this type of case. You have these two different members which are present here. Here this is hinge support. Here this is roller support. Now if we will calculate m will be 9. 2j minus 3, this will be 9. It means that m is equal to 2j minus 3, or you can say that m minus 2j minus 3, this is equal to 0. But this particular left portion is over stiff. देख सकते हो आप, this is over stiff, and this particular part is deficient. This particular part is deficient. Hence, this particular part is unstable. This is unstable. This is unstable. It means that if one part is unstable for the structure, then this particular structure, even if this equation is satisfied, this particular structure will be considered as unstable. Why it is considered as unstable? It is considered as unstable because one part of the structure is not stable. That is, it is deficient. That's why the structure is overall unstable. समझ में आ गया होगा. If you want to check the stability, तो यहाँ पे एक नोट एक ध्यान रखना है. दैट नोट यू हैव टू कंसीडर. ये आपको नोट ध्यान रख के चलना है. दैट इन केस ऑफ स्ट्रेसेस देयर शुड बी इनफ नंबर ऑफ क्लोज्ड ट्रायंगुलर ब्लॉक्स. Closed triangular blocks. If closed triangular blocks will be present, then the structure will be stable always. Structure will be stable. अगर closed triangular blocks होंगे तो structure will be stable always. अगर closed नहीं होंगे वो, then the structure will be unstable. जैसे for example, let's take the example. एक example के लिए let's draw a polygon like this. If this is a polygon, now if you consider this polygon and calculate the stability for this polygon, the number of members के according you can calculate the stability. Number of member is 6. This is hexagon. 2j minus 3 if you will calculate, this is equal to 9. Joint सारे joint है. These all are joints. All these are joints. 2j minus 3 equal to 9. It means m minus 2j minus 3. This is less than 0. It means this is unstable. ये unstable है polygon. Fine. Now what you are doing? You are just क्लोजिंग इट, मान लो मैं इसको ट्राइंगुलर ब्लॉक्स में क्लोज कर देता हूं. फॉर एग्जांपल आई एम मेकिंग द ट्राइंगल हियर. दिस इज द ट्राइंगल, this is the triangle, this is the triangle. What I have done, I have divided this particular polygon by adding a certain number of members, and by adding those members I have converted it into triangular blocks. Now the number of members are 9, 3 member बढ़ा दिया आपने. 2j minus 3 is again 9. It means m minus 2j minus 3, this will become 0. Now the structure will become stable. It means that if the number of triangular blocks are present, then the structure will become stable. This is what I want to explain here. इतना ध्यान रखना है. It means that now you have calculated the external stability as well as the internal stability. Now you know that the stability can be of two types, that is external or internal. Then it comes to overall stability. Overall stability. Overall stability का मतलब क्या होता है? The structure should be internally. What is desirable? The desirable thing is, for overall stability, the structure should be this. What is desirable? The structure should be stable. The structure should be stable externally as well as internally. Externally कैसे निकालते हैं? Number of reaction check करके. Internally कैसे निकालते हैं? Number of displacement check करके, member से compare करके. member ज्यादा होना चाहिए. यहाँ पे the case is this. Let's consider a particular case. अगर आपके पास ये particular frame है, if you have this particular frame and you have to check the overall stability for this frame, to take the overall stability, what you have to do? You have to calculate the reactions, then you have to calculate the number of displacement. Let's say that this is the support, hinge support, this is the roller support here. Number of reactions की बात करते हो. If you are checking it for external stability, external की बात करते हो, external के लिए the number of reactions will be, इस पे 2, इस पे 1, इस पे 2, there can be 2 reactions, there can be 1 reaction, roller support. 3, number of equilibrium equation 3. तो इसका अगर आप निकालते हो, स्टेबिलिटी चेक करते हो, तो स्टेबिलिटी विल बी 3 minus 3, this is 0. It means this is externally stable. Now you check for internal case. अगर internally check करते हो, internally m is equal to number of members is equal to 3, 6, 2j minus 3, this is equal to 5. Now m is greater than 2j minus 3, this is stable internally also. It means this particular structure is overall stable. This is overall stable. ये overall stable है. समझ में आ गया? Let's take the example of one more case. एक और case का example लेते हैं. Let's say that we have this frame, this particular case. You have a shape like this. This is a triangular shape which you have. Now we have hinge support here. We have hinge support here. You have hinge supported all together. Now in this case, the number of members are 2. The 2j minus 3 is 3. Here m is less than 2j minus 3. So this particular structure is internally unstable. ये internally unstable है. अगर आप इसका external check करते हो तो reactions, number of reactions are 4. Equilibrium equations are 3. It means that this is stability. If you'll check, this is 4 minus 3, this is 1. It means this is externally stable. Externally stable. Externally move नहीं करेगा. Internally इसके parts relatively move कर सकते हैं. तो यहाँ एक note आता है that you have to remember. That's why I'm telling you this particular question, that if the structure is externally stable, if the structure is externally stable, then you will say that it is overall stable. You will say that if it is overall stable. But the desirable is कि दोनों में stability आना चाहिए. But if it is not there, if only the structure is externally stable but not internally stable, then it is known as overall stable. Overall stable होने के लिए external stability is mandatory. External stability is mandatory. अगर ये नहीं है तो it cannot be stable. Remember this thing. It is mandatory. अगर ये यहाँ से स्टेबल होता है, यहाँ नहीं स्टेबल होता, तो यहाँ नहीं स्टेबल हो जाता फिर. Because external stability is the mandatory thing. Fine. So this is the concept. I hope you have understood the case. It's A.S. Pandit signing off the stability case of the first part of determination and determinacy chapter. Take care. Bye-bye. Keep on learning. Keep on rising. Keep on accepting.